Einstein's theory of relativity inspired scientists from around the world to begin imagining that time travel is theoretically possible. Imagine for a second that time travel became completely possible in practice. Suppose you decide to go back in time, for example, to meet your grandfather, whom you've never met. You know the exact time and place where your younger grandfather was in the past, and you go there. Since you entered the exact coordinates of his location, the time machine lands right on your unsuspecting grandfather and crushes him to death. It turns out that now your grandfather does not meet your grandmother, which means that one of your parents won't be born, and neither will you. If you didn't come into the world, then you couldn't possibly go back in time and kill your grandfather. Thus, we see how the paradox turns out. Physicists call it the grandfather paradox. Many scholars use it as an argument against the possibility of travel to the past. But I know the solution to this paradox, which means that in the next 10 minutes, you'll also find out why you can't get in trouble by going back in time. And even if you seriously screw up, though in just a few seconds, you yourself will understand. So, what's the solution to the time paradox? To uncover this secret, back in the 1970s, Russian physicist Igor Novikov proposed the principle of self-consistency. This principle is based on the general theory of relativity, according to which the fabric of space-time is curved. Following this curvature, there are special lines that prevent the violation of cause-effect relationships in time. Since time travel is only possible along these lines, it's impossible to change the past and influence the present and future. The physicist Kip Thorne believes that there are wormholes right along these lines. These are hypothetical tunnels leading from one point in space-time to another. Such wormholes suggest that all events are cyclical and self-consistent. This means that time travelers will not be able to change anything. Some physical barriers will stand in their way, or there will be no opportunity to make a choice that could affect something. Therefore, even if you tried to kill your grandfather, you wouldn't succeed. For example, if you point a handgun at your grandfather, it will misfire on every attempt to shoot him. But at the same time, the gun will work flawlessly in any other case when the shot would not cause any changes in the cause-effect relationships of space-time. Later, students at the California Institute of Technology, Fernando Echeverria and Gunnar Klinkhammer, together with Kip Thorne, expanded their understanding of wormholes and tried to solve the grandfather paradox through a game of billiards. They wanted to find out if a billiard ball could be thrown into a wormhole at an angle, so that if it continued along a given path, it would exit the wormhole in the past to collide with itself. This event, therefore, would have knocked it off course, preventing it from entering the wormhole at all. However, through complex mathematical calculations, the researchers found that the physical features of the wormhole itself are designed in such a way that they simply will not let the ball knock itself off course. More precisely, the ball can hit itself, but this will not significantly affect its path of travel. The same thing will happen with your grandfather and the handgun. He might tell you a story about the past when he was threatened with a gun by someone similar to his grandson or granddaughter, but his life story will otherwise remain unchanged. Suppose having all this information about Novikov's principle of self-consistency and wormholes, for the sake of curiosity, you start firing from your handgun at your grandfather because you're completely sure that the laws of physics will not let you kill him. However, the unexpected happens. The bullet impacts with your grandfather's head. In a panic, you get into the time machine, return to your time, and find that your family home and all other traces of your existence are gone. The fact is that for the operation of the Novikov principle to work, there must be additional mechanisms that will cause the gun to jam or force your grandfather to dodge the bullets like Neo in the Matrix. Only such laws of physics capable of preserving causation from the careless hands of time travelers have not yet been discovered. Therefore, the entire scientific community has rejected Novikov's principle of self-consistency. So, the grandfather paradox requires a different solution. Fortunately, such a solution exists and is given to us thanks to research into the behavior of light. Back in 1803, when scientists were arguing about what light waves or light particles are, Thomas Young put an end to this discussion. He conducted an experiment in which he exposed a beam of light to an opaque screen with two slots. It was expected that two parallel lines of light would come out through the holes, but the light passed through the slots like a wave. Then, other researchers decided to repeat the same experiment, but not with a whole beam of light, rather with a single electron. It was assumed that the electron would pass through one of the two holes, but to the astonishment of the scientists, it simultaneously made its way through both slots. Thus, scientists discovered quantum mechanics, in which an electron is both a particle and a wave. Based on this, physicist Hugh Everett proposed a theory of multi-world interpretation, according to which the universe is divided into two worlds. One world in which an electron passes into the first gap, and a second world where it slides through the other gap. This has a direct bearing on the case of your murdered grandfather. According to Everett's theory, after your grandfather's death, you've created a new alternate universe in which your grandfather dies after being crushed by a time machine. The same thing happens if you shoot your grandfather with a gun, but in the original world, nothing has changed. Grandfather is alive and well. You could still have been born, after which you traveled back in time and divided the universe in two. A similar principle is demonstrated in the short film 1 Minute Time Machine, when the main character, each time traveling just 1 minute into the past, kills himself in the primary world and creates a copy of himself in the new alternate universe. We could put an end to this, but there's one more time paradox that just can't be solved. It's called the ontological paradox and is often contrasted with the grandfather paradox. Imagine that you are a young man who went to the past, met a woman who later became pregnant from you, and you were her newborn baby. Then, when you grow up, you go back in time to conceive yourself. This, in turn, will lead us to an endless cycle in which you don't have a clear, visible origin. Let's turn to another example. Let's say you created a time machine and went to the past to deliver instructions to yourself on how to create this time machine. It turns out that any object, information, or person sent to the past starts an endless cycle, and the origin of the object becomes unclear. Such a paradox assumes that the past, future, and present are not defined, which means that talking about time travel is impossible even in theory. But the numbers tell us something very different. Einstein's gravitational field equation implies the existence of such infinite time cycles. As experience shows, many theories mathematically deduced by Einstein are sooner or later confirmed in practice. All this does not guarantee real time travel. According to the calculations of Stephen Hawking and Roger Penrose, there's an obstacle in the wormholes, the so-called Cauchy horizon. Passing through it, you'll be struck by an endless impulse of energy that will erase your entire past. However, Kip Thorne believes that this can be avoided if the wormhole consists of a special kind of exotic matter. But this is a topic for another episode. Nevertheless, most likely, we live in the primary universe, which will only begin to split apart when humanity learns to travel to the past or the future. Then, many scientists will begin to disappear from this universe for the sake of research. It may turn out, though, that their discoveries will benefit only the residents of parallel universes. If you had such an opportunity, would you leave your native dimension to start life from scratch in a parallel reality? Let us know in the comments.